I know it's especially frustrating because you're doing everything you've been told you have to do: fasting, controlling carbohydrates, not drinking alcohol, and yet when you go and check your blood sugar, the test results show that the number doesn't go down. You're still inflamed and still tired. But pay attention here, because it's not a failure of your willpower. What you're probably experiencing is simply a hardware blockage. When your cells start receiving a constant avalanche of glucose, there comes a point when they simply decide to go deaf. And they literally block its entry to protect themselves from the impact of sugar. It's purely a defense mechanism. And it's right here where the real disaster begins. And also where the concept that worries you so much appears, and that today we're going to dissect. Insulin resistance. And what is insulin resistance? Well, let me explain. Insulin is like the messenger that brings the message. There's energy outside. And when the cell goes deaf, the messenger is left outside, knocking on a door that no one opens. And this is the beginning of the disaster. Since the energy doesn't enter your cell, your pancreas misses the message received signal. And when it detects that the blood sugar level is still remaining dangerously high, and not a single cell is responding to the insulin, then the pancreas suddenly goes into a full-blown state of panic mode. It's like it turns into a frightened manager, thinking that the message wasn't strong enough. And then it starts producing insulin at full speed, trying to shout even louder. Keep in mind that the pancreas, as a supply manager, what it does and what it has to do is monitor the blood. And when it sees that there is sugar circulating, it expects to see that level drop because the cells are absorbing it. But it turns out the cell has gone deaf and the pancreas doesn't know it. The sugar stays outside in the blood, and that silence from the cell is what drives it crazy. And this excess insulin that it starts producing, which in fact it originally does to protect you, is what nevertheless ultimately causes inflammation, damages your tissues, and above all, completely blocks your fat stores. Well, when this situation occurs, you find yourself trapped in what is absolutely and undeniably a dangerous, vicious cycle of insulin resistance. As I was saying, the pancreas misses the acknowledgement signal, and since it doesn't detect that the sugar is entering the engines, it goes into panic mode. It thinks that the sugar remains high in the blood because it hasn't sent enough messengers. And so, frightened, it starts producing more messengers, in other words, more insulin. This effectively results in a logistical deadlock, which is difficult to resolve. And some of you, upon hearing this, might say to me, "But Jose Maria, if sugar is an acid, a powerful chaotrope that completely melts my delicate liquid crystal, why on earth would I ever want to force it to enter inside?" Well, look, even if it surprises you, order must be established. Sugar trapped in the blood is a real poison that oxidizes your vessels and your nerves. And on the other hand, you have your cells, which are starving because they need some of that glucose for their mitochondria to function. Therefore, the key here is not flooding, but simply moderation and order. We have to do something. And we don't want to throw the doors wide open so that the sugar comes in and caramelizes everything, because that would mean heading straight for glycation and complete disaster. What we're looking for is to restore an orderly flow, and we want only the exact amount that the mitochondria can process and burn cleanly to enter. We're not going to try yelling louder at a cell that simply can't hear. What we're going to do is perform a biophysical bypass. And this is what it's all about. Today's video, we're going to break that vicious cycle. And we're going to try to put an end to insulin resistance once and for all. Well then, to do this, we're going to use physics to force the sugar to enter the cell, but through an emergency route. And to achieve this, we're going to use the pressure from your muscles and the impact of cold. By feeding the cell through this back door, cellular hunger will disappear, and the pancreas, seeing that blood sugar drops, will be able to stop producing excess insulin. And we will manage to bypass resistance in a completely natural way. What we're going to do today is try to regain control of the machine, and in the process, by doing this, you will learn how to avoid insulin resistance. I invite you to come down with me to the engine room, because what we're going to do is reset your sensors and restore peace to your operating system. And to understand why your cell has decided not to listen, thank you. We have to stop seeing it as just a simple bag of water. The cell is much more than that. And as I was saying a moment ago, what you're likely experiencing is not a failure, but a survival protocol of your own cell, which doesn't want to be completely destroyed or acidified by sugar. And to understand how that protocol is broken, we need to go down to the level of the quantum hardware of your cathedral. Well, this is where the fundamental work of Dr. Gerald Pollack from the University of Washington comes into play, whom we've talked about, whom I've already discussed with you in several previous videos. Pollack discovered that the water inside your cells, thank you. It turns out that it's not the same water you drink. It's a fourth state of matter, a liquid crystal that we call structured water, or H3O2. And this liquid crystal, in reality what it is a negatively charged battery. And it's the conductive medium that allows any signal, such as insulin, to travel from the membrane to the nucleus. Without this conductive gel, communication within your body simply doesn't exist. It's as if a total logistical blackout had occurred. And you might ask me, what does sugar have to do with all of this? Well, you see, glucose creates a tremendous osmotic pressure, which acts as a contaminant of that liquid crystal. And here, I'll make a brief aside to clarify something for you. Osmotic pressure is basically the force of attraction that sugar has to draw water toward itself. When you have an excessive amount of glucose circulating outside your cells, that osmotic pressure and tension becomes so incredibly strong that it actually starts to draw out and deplete the water from within them. Deep inside your microscopic cells, it constantly performs this process to try to balance the internal mixture. But you see, it is almost as if the excess sugar were physically squeezing your delicate cells from the very inside. And the excess sugar, by stealing electrons from H3O2, causes the gel to become opaque and lose its ability to conduct electricity. And why is that? You might ask me. Well, it's actually very simple, because structured water is not just a gel, it's above all a semiconductor. And if sugar steals electrons, the semiconductor simply becomes a faulty insulator. The insulin signal doesn't fail to arrive, it just suffers a massive voltage drop before it can reach the nucleus. In engineering, we call this a loss of dielectric insulation. And when insulin rings the doorbell at the membrane, the signal tries to travel inside, but since the medium is dirty, the signal gets lost and turns into pure static noise. And here you see, keep one thing in mind. Insulin does not enter the cell. it is the messenger. Think of the cell membrane as a closed fortress that has an intercom, and that intercom is the insulin receptor. When insulin arrives, it rings the bell because its job is to signal that there is energy, that is glucose, waiting outside. By pressing that button, it is supposed to trigger and activate a mechanism within the cellular structure that opens up specific molecular gates so that the sugar can finally enter. But that door doesn't open because there's already too much noise inside or too much dirt from the excess sugar. And so the signal doesn't reach the inside, or it simply arrives distorted. The body thinks that no one is ringing the doorbell and therefore the doors don't open. The sugar stays outside and poisons the system. But you see, the damage doesn't just stay in the water, because this is where glycation comes in, which is the factor that makes this blockage a physical one as well. Just think that sugar is like a sticky candy that clings to your proteins and your insulin receptors. Those receptors, which are like antennas that should vibrate when they're covered in that sticky candy, simply end up caramelized. They get covered with a hard crust that keeps them from moving, and it's as if the terminals of a battery became corroded. The connection simply becomes non-existent. And faced with this chaos, a dirty conductive medium and rusted antennas, the cell simply activates its defense operating system and shuts the doors to prevent the engine from exploding due to oxidative stress. The result is a deadlock. The cell protects itself, your blood floods with sugar, and your pancreas. In the face of silence, it starts to scream and produces more insulin, thinking that's the solution. In reality, this is a serious problem. A repetitive blockage has occurred. And that's why today, we're not going to try to repair a burnt-out antenna. What we're going to do is ignore it. And we're going to use the sheer overwhelming brute force of physics to completely bypass this physical blockage. And we're going to achieve this specific result through the power of piezoelectricity. Insulin is a chemical signal which, as such, is slow, and it requires healthy receptors. However, the mechanical pressure obtained through piezoelectricity is a physical signal and high frequency. It's as if you tried to send an email over a Wi-Fi network that's down, that is insulin, but you think it over and finally decide to use a fiber optic cable instead. Thank you. Which is buried in the concrete, in other words, biotensegrity. And that fiber optic cable doesn't need the router to work because the signal arrives purely through physical impact. And here, with this, I've just reminded you of a concept we've talked about before. Your body is a network of biotensegrity. Dr. Donald Ingber, a Harvard doctor, explained it. Exactly, it was when he explained it so clearly when he said that your biological cells are supported by a complex framework of cables and struts under constant tension, which behave very much like crystals and are always in a state of continuous unwavering tension throughout the body. This means that any pressure you apply to one end of your body is transmitted instantly to the nucleus of every cell. And this is not a message that travels through the regular mail of the bloodstream. This is a vibration that travels at the speed of sound through your cytoskeleton. They are biological crystals, and that is the network, and the physics is clear. When you compress a crystal, you generate an electric current, and when you perform a tension exercise or explosive force, you generate a powerful, pure electric spark that travels swiftly through the intricate metal cables of your entire structure, directly to the central nucleus, completely bypassing the thick, dirty liquid crystal and the heavily rusted external antennas. This current becomes a priority signal, one that arrives directly at the control panel of the AMPK engineer, who, remember, is our crisis manager. And the engineer, upon detecting this spark, activates the boarding protocol and gives a direct order to the GLUT4. And these GLUT4s are like real delivery vans that were just standing around in the basement with their arms crossed because the insulin intercom was simply broken. But under the powerful and sudden jolt triggered by the AMPK enzyme, these transport vesicles rapidly shoot up and migrate to the surface, proceed to open the side windows of the cellular cathedral, and begin to suck up the glucose sugar molecules at a truly dizzying and incredible speed. And this is where it happens, the miracle happens. By feeding the cell through this back door, cellular hunger disappears. The pancreas, seeing that the sugar finally drops, stops producing insulin as it was doing, and, in short, with this bold and courageous move, what you have managed to do is restore chemical peace, solving it with physics. But you see, this critical emergency maneuver also has a truly wonderful side effect. When your muscles contract intensely under this high level of tension and activate this complex internal wiring, they also simultaneously release a specific type of myokine, which is a powerful movement hormone known as irisin. And as Dr. Bruce Spiegelman discovered at Harvard, irisin acts as the primary foreman that orders a complete and thorough overhaul. And it travels to your white fat, which is a cold and passive storage, and orders it to install internal boilers to transform into gray fat. Pay attention to this because it doesn't just order the renovation. It also installs the voltage sensors in that new fat. And to put it in a way that's easier to understand, gray fat is, let's say, intelligent because it responds to voltage, whereas white fat is completely dumb. It only responds to the hormone insulin, but we already know that this hormone happens to be blocked. So I imagine all of this will help you understand why we look for a bypass. Well, by turning those inert storage rooms of white fat into active thermal power plants, your ability to process energy simply increases exponentially. Now, you don't just burn sugar when you move, you actually have an infrastructure that consumes it even when you're at rest. And that's the real biophysical bypass we were looking for. And you might ask me, and this? Why is this a bypass? Well, it's very simple, because gray fat, when activated by irisin and mechanical tension, starts to suck sugar from the blood on its own, since it needs to feed those new boilers. In other words, you've created a new energy consumer where before there was only a storage room full of useless things, a dumb, smooth white fat. And this is the real victory. Not only have you managed to bypass the blockage, but you're also installing new hardware that will prevent the deafness from happening again. But it also has to be said that all of this is useless, all the effort we've made, if once we've forced our way in through the window, we find that the wires inside are covered in rust, because this is the part we sometimes forget. The famous electrical deafness isn't just a problem of having headphones on. Often, it's actually a problem of physical dirt. And I mentioned this to you a few minutes ago. If your receptors have spent years bathed in excess glucose, glycation has occurred. Your antennas have simply become caramelized. They've been covered by a rigid crust that prevents them from vibrating at the correct frequency. This, just so you get an idea, is like trying to tune a radio whose antenna is buried in dry cement. Well, it is certainly a very good thing that we finally activated the gray matter, but we still find ourselves in need of the specialized chemical stripper that effectively cleans all the dirt off those old antennas, so they can clearly hear the voice of Sergeant Insulin once again. And for that, I want you to pay very close attention now, because we're going to use the most absolutely fundamental and essential force in all of physics, the complex thermodynamics of extreme cold. And this is where the work of Dr. Shingo Kaimura comes in, also from Harvard. He is the leading expert on how cold affects our energy efficiency. And to understand this, we have to go back for a moment to the mitochondria. Think of it as if it were a dam where protons pass through a turbine to produce ATP, energy. And that's the standard operation. But when the cold intensifies and your core temperature is at risk, the system activates an emergency protocol. And you probably didn't know this. UCP1 or thermogenin. In engineering, this is called thermal uncoupling. And what UCP1 does is open huge pores in the dam. And the protons no longer pass through the turbine. Instead, they fall into the void and generate heat through friction. In engineering, this is called thermal dissipation. It's basically a thank you. It's basically a controlled short circuit that turns your mitochondria into high-powered heaters. And here, sugar is burned not because the body needs ATP or, to put it more simply, energy to move. No, it's burned because the body needs emergency heat. And this explains why cold lowers blood sugar even when you're at rest. Something that, by the way, usually surprises diabetics enormously. It's about burning fuel to heat the boiler, not to power the engine. And in a situation like the one I'm describing, the demand for heat is so intense that the cell enters a state of mitochondrial hunger. And it's not that it's lacking energy, it's simply that it's wasting it on purpose to keep you alive. This suction of fuel is so powerful that it forces the cell to carry out emergency maintenance, sweeping away oxidized proteins and mobilizing enzymes that begin to dissolve that sugar crust caused by glycation, the one I was telling you about. In other words, the cold acts like a true factory reset. You're not just burning glucose at a dizzying speed to heat your own system, but you're also forcing your membranes to regain their fluidity. It's as if you were putting the terminals of a sulfated battery into a solution that leaves them completely shiny like new. And after the thermal shock, when you return to normal temperature, your antennas are clean, clear, and ready to listen again. You've gone from being deaf to regaining the clarity of the signal. But remember, this only works if you stop living in that eternal spring we're all in at 21 degrees Celsius, which, on the other hand, is what has oxidized your switches. When you go out into the cold, you're forcing your cathedral to recalibrate its thermostat and its chemical sensitivity. Well then, now we have the emergency entrance open and the hardware clean. But a good engineer knows that for a machine to regain its factory precision, it's not enough to fix it while it's running. Sometimes you have to turn off the generators, empty the conduits, and let the maintenance team do their job. This is what I call strategic silence, or, to put it in a way you'll understand better yet, fasting time. And many people think that fasting is just a way to not eat in order to lose weight, but that's not at all my view. In our cathedral, silence, that is fasting, is a resonance calibration maneuver. And you'll see in the previous video, if you remember, we saw that silence served so that Sergeant Insulin would simply stop shouting. But today the goal is different. We want your workers to go out and perform what is called reverse glycation. Your insulin receptors are proteins that, as we've seen, become rigid when they're bathed in the caramel of sugar. Well then, by entering electrical silence, that is, by fasting and stopping the supply, you are activating the Sirtuins. And these are your finest maintenance workers of all. Their job is not to burn fat. Their job is to physically detach the sugar from your proteins. And they are responsible for polishing the terminals of your batteries so that conductivity returns to being perfect. But they don't just detach the sugar. In addition, they perform a task that in engineering we call deacetylation. That is, they act like a chemical cleaning technician who uses a specific solvent to remove rust from electrical contacts, from the receptors, and restore their ability to vibrate. And you might still ask me, but what happens if an antenna is so damaged that it can't be fixed anymore? Well, this is where the legacy of Dr. Yoshinori Osumi comes in, who won the Nobel Prize in 2016. He showed us the blueprints of autophagy. When the system detects that no fuel is coming in and the energy sensors are silent, the cell, what it does is identify the defective components, and instead of throwing them away, it recycles them. It creates an intelligent pouch called the autophagosome, which wraps up those oxidized receptors and takes them to the melting furnace. And there, it breaks them down into their basic components to manufacture new hardware, as if it were hardware fresh out of the factory. To put it in a slightly different way, when you choose to fast, you are definitely not just starving yourself. Instead, you are carrying out a true, comprehensive biological and technological internal renewal process deep inside you. You are systematically retiring and recycling your body's old, worn-out cellular equipment, so that when you finally turn the biological machine back on, your cells have a remarkably sharp and incredibly keen ear, one that is fully capable of detecting even the very faintest whisper of insulin in your system. And with this, we close the circle of your recovery. You have learned to identify the acid from sugar, to install the fat shield, to flip the insulin switch, and today to perform the bypass, to regain your sensitivity. You have gone from being a patient waiting for a diagnosis to being the chief engineer of your own life. And so that your operating system doesn't collapse again, what you need to do is remember these 4 fundamental laws we've learned in these videos. The first, avoid acid, that is sugar. Because it's not just energy, it is above all an agent of entropy that melts your liquid crystal. Second, install the shielding. Use the high-fidelity fats I mentioned so that your membrane can become a perfect insulator. Third, manage the switch. Lower insulin with fasting so that deep cleaning can begin. And fourth, tune the antenna. And for that, you should utilize mechanical tension and exposure to extreme cold to effectively restore sensitivity through thermal and physical shock. At this point, I want you to understand the structural difference. You see, conventional medicine, when faced with insulin resistance, often offers you a chemical crutch, a pill that tries to patch the software but leaves the hardware damaged and the machine broken. And this, from my point of view, is not health. This is merely managing obsolescence. And what I'm proposing to you is your metabolic sovereignty, that you stop being a passive user of pharmaceuticals and become the chief engineer of your own biology. You see, you no longer have to depend on external patches to manage your blood sugar. Now you have the maintenance blueprints to reset your voltage and recalibrate your sensors every time the needle goes out of the green zone. Or if you prefer it another way, instead of using the term needle, every time it goes out of the green zone, think of it as having learned to calibrate your voltage every time the needle drops out of the zone of your own sovereignty. To put it simply and concisely, you should no longer have to remain a helpless victim of your lab results. You deeply understand the intricate software code, you have mastered the complex physics of the underlying hardware. And therefore, your magnificent cathedral is finally ready to shine brightly for the world to see. But pay attention, because a perfect antenna is still vulnerable if it is disconnected from the earth. In my next video, we will go down to the ultimate foundations and explore with you the iron triangle. That is, pressure, earth, and light. Together, we are truly going to discover the profound methods of harmoniously synchronizing your liquid crystal with the deep resonance of the planet, so that your personal energy finally becomes entirely and utterly inexhaustible. And if you like the video and think it could be useful to others, you would do me a great favor by sharing it. You will help me spread knowledge and awaken others from that metabolic lethargy that keeps them asleep in a dark cathedral. As I always tell you, go forward, always forward. And I'll read your comments. Thank you very much for being here.